Hi everyone, welcome to E-Content Development Center, Majlis Arts and Science College, Puramannur. Myself, Shemina TT, Assistant Professor, PG Department of Mathematics. Today, we are going to discuss a topic, functions. After watching this video, you can identify the basic idea about functions and what is function composition and what are linear functions. Now, we are going to discuss functions. A function is a rule that assigns every object in a set A to exactly one object in a set B. Now, in the definition, the set A is called domain of the function and the set of assigned values are called range of the functions. Now, we can discuss some examples. Consider the first example. Here, we can take set A as -4, -2, 0, 2 and 4 and set B as -3, -1, 1, 3 and 5. Now f of x is a function from set A to set B where f of x maps -4 to -3, -2 to -1, 0 to 1, 2 to 3, 4 to 5. Therefore, f of x is a function since here every element of A has a image and a unique image. So, f of x is a function. Here the domain of the function f of x is set A, that is set -4, -2, 0, 2, 4 and the range is the set of assigned values of the set B. Here all values are assigned. So, the range is -3, -1, 1, 3 and 5. So, it is clear. Now, we are going to discuss another example. Here, we take the same set A as the domain, that is set -4, -2, 0, 2 and 4. Now, B, the set B is taken as set 16, 4 and 0. Here, g of x is a function from set A to set B. Here, g of x maps -4 to 16, -2 to 4, 0 to 0, 2 to 4 and 4 to 16. So, here every element of A has a unique image. So, clearly g of x is a function. Now, here the domain of g of x is set -4, -2, 0, 2 and 4 and the range is set 16, 4 and 0 and the range is set 16, 4 and 0. Now, another example. Consider the first example. Here we take set A as set 1, 2, 3, that is the domain of the function is set 1, 2, 3 and take B as set P, Q, R. Here 1 maps to P and 2 and 3 are maps to Q. So, here the range of the function is set P, Q. Now consider another example. Here we take set A, the domain as the set 1, 2, 3 and the set B as set P, Q, R. Here this function assigns 1 to P and 2 and 3 to Q. So, the range of the function is set P, Q because R has no element assigned to it. So, R is not in the range. So, the range of the function is here the set P, Q. Now, consider another one. Here the same set A and here the same set A and B are taken, that is set A as 1, 2, 3 and set B as P, Q, R. But here 2 has 2 image, 2 maps to P and Q also. And so, this is not a function because 2 has 2 images. This is not possible for a function. So, second example is not a function. Now, consider another example. Here, we take set A as A, B, C, D and set B as P, Q, R. Here, B has no image. The element B has no image. So, it is also not a function because to become a function, we must have every element has a unique image. So, the third one is not a function. Second and third ones are not functions. First one is a function. It is often represent a function by a relationship y equal to f of x. Here y and x are variables. X is said to be dependent x is said to be independent variable and y is the dependent variable. For example, y equal to x plus 1 represents a function. Here in the second example, minus 4 maps to 16, minus 2 maps to 4, 0 maps to 0, 2 maps to 4, 4 maps to 16. Here we can write f of x as x square, that is minus 4 maps to 16, that is minus 4 maps to minus 4 square. So x maps to x square and minus 2 maps to 4, that is minus 2 maps to minus 2 square, 0 maps to 0, that is 0 maps to 0 square, etc. So here f of x can be written as f of x equal to x square from set A to set B, where set A is set minus 4, minus 2, 0, 2 and 4, and B is the set 0, 4, 16. So here f is a function from A to B, f of x equal to x square. Now we are going to discuss injective function. What is an injective function? A function is said to be injective if it maps distinct elements to distinct elements. Consider the example. Here we already discussed the first example in previous case. Here f of x maps minus 4 to minus 3, minus 2 to minus 1, 0 to 1, 2 to 3, 4 to 5. Here every distinct elements maps to distinct elements. So here f of x is a injective function. Now consider the second example. Here minus 4 maps to 16, also 4 maps to 16. So distinct elements maps to same element. So the second example is not an injective function. First example is an injective function, second is not an injective function. Now we are going to discuss surjective functions. What is a surjective function? A function from a set A to a set B is said to be surjective if for every y belongs to B, there exists an x belongs to A such that f of x equal to y. That is, every element of B has a pre-image under f. So then f is called a surjective function. Consider the example. Here the set A is x, y, z and w, and set B is set 1, 2, 3. Here every element of B is the pre-image. Here every element of B is the pre-image of some element in A. So it is a surjective function. Now consider the second example. Here the set A is set x, y, z and w, and set B is set 1, 2, 3 and 4. Now we cannot find an x belongs to A such that f of x equal to 4. That is, the element 4 in B has no pre-image. So the second example is not a surjective function. Now we are going to discuss the composition of function. Given two functions f of x and g of x. The composition f of g of x is a function of x formed by substituting x equal to g of x in the formula for f of x. Consider f of x equal to x square plus 3x plus 1 and g of x equal to x plus 1. We have to find f of g of x. So instead of x, we substitute x plus 1 in f of x. So f of g of x equal to f of x plus 1, that is x plus 1 whole square plus 3x plus 1 plus 1. After solving this, we got f of g of x equal to x square plus 5x plus 5. We can also find composition g of f of x in the similar way, but f of g of x need not always same as g of f of x. In the above example, g of f of x equal to x square plus 3x plus 2. So f of g of x not equal to g of f of x. So f of g of x not always equal to g of f of x. Now we are going to discuss linear functions. What is a linear function? A linear function is a function which changes at a constant rate with respect to the independent variable. The graph of a linear function is always a straight line. Now a linear function has the form y equal to mx plus b, where m and b are constants. Consider the example. Here the function y equal to 3x plus 2, which is a linear function whose graph is a straight line. Now consider some functions used in economics. First one, the demand function d of x. The demand function d of x for the commodity is the price p equal to d of x. It must be charged for each unit of the commodity if x units are to be sold. And the second one is the supply function s of x. The supply function s of x for the commodity is the unit price p equal to s of x at which producers are willing to supply x units to the market. And the next one is the revenue r of x. The revenue r of x obtained from selling x units of the commodity is given by the product r of x equal to x into p of x. And the next one is the cost function c of x. The cost function c of x is the cost of producing x items, x units of the commodity. Next one is the profit function p of x, capital P of x. Profit function p of x is the profit obtained by selling x units of the commodity, and it is given by p of x equal to r of x minus c of x. So today we have discussed what is a function and what is a linear function, what is a composition of function, injective function, surjective function, and their examples. Hope all of you are understood my topic. Thank you.